Hello, Honors Pre-Calculus. Welcome to week 2 of our online learning. Today we are going to start our adventure with parabolas. Maybe some of you looked at that Desmos activity that Miss Cronky and I both posted. Maybe you didn't. Regardless, it doesn't matter. Today and the rest of the week, we're gonna talk about parabolas. So I know that we've talked about parabolas before, but we are going to talk about them in relation to our conic sections. And we're also going to, in lesson 2, Miss Cronky will even show you some parabolas that open left and right, as opposed to just up and down like we're going to do today. So let's go ahead and get started here. Okay, so you saw the double napped cone with Miss Cronky when she talked about circles. So here is our double napped cone with our plane going through, and it's creating a parabola. Okay, we can have wide parabolas, we can have skinny parabolas, but one of the conic sections is a parabola. The official definition of a parabola is this. A parabola is a set of points, x and y, in a plane that are equidistant from a fixed line directrix and a fixed point focus not on the line. Okay, remember this is a video, so anytime you need to pause, you go for it. Okay. The directrix and focus are two things that we are going to graph with our parabola. And what this is saying is that the directrix and the focus are equidistant from any point. Okay, so all of the points on our parabola, if we measure the distance to the directrix and the distance to the focus, those distances will be the same. So let me show you a picture. Okay. Trying to make sure I don't cover it up with my picture here. Okay, so here's the vertex. You have always known that there's a vertex with a parabola. Okay, now in addition to the vertex, we are going to plot a focus. So the focus is this point that I just highlighted in yellow. It is a point inside the parabola along that axis of symmetry that you're used to seeing. Okay. The directrix is then a line outside of the parabola. So if the focus is inside, the directrix is outside. And this line, notice how it's perpendicular to that axis of symmetry that you're used to seeing. Okay, so the cool thing about a parabola is that all the points are equidistant from these two things that I just talked about. So if we take, I'm gonna go in, let's see, green sounds like a good color, like this point right here, okay? That green point that I just highlighted, if I measure the distance to the focus and to the directrix, it's the same distance, okay? Let's take another point. If I look at this point right here that I just highlighted in green, if I measure the distance from that point to the directrix, if I measure the distance from that point to the focus, they're the same distance, okay? And that's true for any and every point that I pick along a parabola, and that's what makes a parabola special, okay? So you've worked with parabolas a lot over your math career, but we've never really talked about this unique definition that it has. Okay, so we are going to talk about two different kinds of parabolas. We're going to talk about vertical and horizontal parabolas. So horizontal parabolas, Ms. Cronky will talk about in our second video. Today we're going to focus on vertical parabolas. First of all, you're used to that. They open up, they open down, okay? But what you're not used to is our new standard form. So this is the standard form of a vertical parabola. I'll give you an opportunity to go ahead and write that down. Okay. Now, a couple things that we need to talk about with this. P is not going to equal 0, okay? Also, the vertex is going to be at H, comma, K. Okay, what's nice about our conic section standard forms is that they're pretty consistent with how we pick information out. So HK was your center for your circle. Now HK is our vertex for our parabola. Okay, now I could give you a formula for our directrix and our focus, but instead I'm just going to tell you that both our directrix and our focus are going to be P away from the vertex. Okay, we know that the focus is inside and we know the directrix is outside. So if we know what P is, hey, this guy right here, then we can count on our graph where we need to place the focus inside and where we need to draw our directrix outside. Okay. So here's a picture of what it's going to look like. The first thing that you are going to draw is your vertex. Okay. Then whatever P is, you're going to count P along the axis of symmetry inside your vertex or inside your parabola. So if it's opening up, you're going to count up. If it's opening down, you're going to count down. Okay. Then the other direction, you're going to count P. So here we went P inside. Then we're going to go P outside to draw our directrix. Okay. Then once you have that all figured out, then you can draw in your parabola. Okay. So what am I looking for in your graph? I'm looking for your vertex. I'm looking for your focus, and I'm looking for your directrix. Those three things need to be labeled, and I need to see them on your graph. Okay, so let's go through a couple examples so you know what we're looking for here. Okay, so here, whoops, sorry guys. Let me make it a little smaller. Okay, so here we have x minus 3, the quantity squared, equals 8 times the quantity y plus 2. Okay, let's go back up for a minute and talk about how I know that this is a parabola. Okay, notice how our parabola has one variable squared, while on the other side, that second variable is only linear. Okay, so I can recognize right here that we have a parabola. The x is squared, but the y is not. Okay, and notice how they're on two different sides of the equation. Okay, so the first thing we need to pick out here is that our vertex is at HK. Okay, well, x minus h would mean h is 3. Y minus k would mean that y is -2. Okay, now this coefficient right here is always 4p. Well, if h is 4p, then that is going to mean that p is 2. Okay, so I'm going to come down here and I'm going to graph my vertex at 3, negative 2. I'm just going to label it B for vertex so I know, okay? Now, let's talk about how we know if this opens up or down, okay? RP is a positive number, which means our parabola is going to open up, okay? So, since P is 2 and our parabola opens up, I'm going to count up 1, 2 units for our focus. So our focus is at the coordinate 3, 0. Okay. Now, our directrix needs to be P units the other direction. So now I'm going to count P units, which was 2, down, okay? But instead of a point, it is actually a dotted line that I want you to draw, okay? So that's our directrix, and we're going to have to actually label it as a line. So this is the line y equals negative 4, okay? So I've labeled my focus, I've labeled my directrix. The last thing that we need to do is actually draw our parabola, okay? And there's our graph, okay? Now, I will say that sometimes our parabolas are going to be wider, sometimes they're going to be skinnier. Right now, I just want you to draw the parabola and we can worry about skinny versus wide at a different time, okay? Okay, our second example is one that is not in standard form. So I wanted to go through with you the process that we would need to take to get it into standard form and then graphing it from there, okay? So let's talk about, first of all, how we know from this general form that it is a parabola. Notice how we have one term that is squared and all of the other terms, well, I guess with a variable, I won't highlight that there. All of the other terms are linear. So since only one variable is squared and not the other one, we know that this is a parabola, okay? Oh, that is not what I wanted to do. There we go. Okay, so in order for us to get it into this form up here, notice how we need the square of a binomial on one side and our linear information on the other side, okay? So you heard me say the word square of a binomial, which means we are going to have to complete the square. So I already have our information organized where x squared and then minus 2x follows it. So it's actually set up really nice for us. So we have x squared minus 2x plus a mystery number. We're going to complete the square with whatever variable is squared, okay? Plus 12y plus 25. And then we know we're going to need to balance out our equation. Oh, I'm sorry, guys. There we go. Okay. So when we take our b over 2 squared, okay, we're completing the square with the number 1. So I'm going to add 1 and subtract 1. Okay. So what we have is x minus 1, the quantity squared, plus 12y plus 24 equals 0. Now, we've completed the square, which is awesome, but we haven't actually got it into standard form. If we look back at that standard form, we notice how we have x minus h squared on one side, but then y minus k is on the other side. So I'm going to keep x minus 1, the quantity squared, and I'm going to subtract over our other terms. Anything else has to go over the other side. Okay? But we're still not there yet because we still don't have y minus k. So in order to get just y minus k, whatever our variable, or I guess our coefficient is in front of that y, we're going to need to factor out. So I need to factor out negative 12, so that left over is y plus 2, and now I can see my y minus k. Okay, so now I want you to think about, before we get going, which direction this parabola opens. If you said that this parabola opens down, you are correct. Since our p is going to be negative, okay, that's actually 4p that I highlighted, but negative 12 is 4p. We know that p is going to be negative. Our parabola is going to open down. Okay. Let's do red for fun. Okay. All right, so let's pick out our vertex. Okay, we need 3 things: vertex, focus, directrix. So our vertex, number 1, our vertex is 1, negative 2. I'm picking out the x minus h and the y minus k. 1, negative 2 is right here. It's my vertex. Okay. You don't actually have to write V. I'm just trying to connect the dots in case you have to like rewind or you're confused about what that is. Okay. Now, I highlighted negative 12. Negative 12 is where we see the 4p. So 4p is negative 12, which means p is negative 3. Okay, that negative is telling us that our parabola is opening the other direction. So in this case, it's opening down. So when I go to plot my focus, that's the direction that I'm going to go. Negative 3, I'm going to go down 1, 2, 3. So our focus is actually at 1, negative 5. Okay. Then our directrix is p units from the vertex in the other direction. So since we went down for our focus, we are going to go up 3 units and draw a dotted line perpendicular to that axis of symmetry. So our directrix is at y equals, because it's a line, 1. So now the last thing we need to do is just draw in our parabola, nice and smooth, opening down. Okay. Thank you for joining me on our lesson today. We will see you next time.